Hi guys, welcome to Learn Electronics Repair, and I have a plain brown box. This arrived today. I know what's in it and you're going to find out in a moment, and this could be something really interesting. Okay, let's have a look. So this is a multimeter. The Tooltop ET13S. But this is not just a multimeter, this is a multimeter with another facility built in. We've seen plenty of scope meters. Well, this is the first time I have seen an infrared camera meter. Okay, so we have here a multimeter with a built-in infrared camera. Yeah. Let's have a quick look on the website first, and then let's have a look at the item itself. And this is the ET13S. So we see there are two versions, one with the macro lens, one without the macro lens. So you can see a little bit of difference in price there. I have the version with the macro lens. The resolution of the thermal camera is 192 by 192 pixels. That is pretty standard, but pretty good for a decent quality thermal camera. It has a refresh rate of 20 Hz on the thermal camera, which again is pretty decent. 2.8 inch screen, English Chinese. It's saying please use your nails to touch the screen. Okay. We can see the optional macro lens here. I do have that, so we'll try it with and without. So how about that? A multimeter with a built-in thermal camera. We can see the price also is pretty good, to be quite honest. That is worth free shipping. To me, this may vary on where you are. This also includes VAT. I would get 21% off that because I'm in the Canary Islands. So that thing is going to cost me about $38 less, 38 euros less than that. That's a good price. Okay, so let's have a look to see how well this thing works. If they've implemented this well, decent multimeter with the thermal camera, this could be very interesting, I think. First thing I'll notice, this has quite a reflective screen. Yeah, I have some very bright overhead lighting, so we'll see how well that works. It comes with a pretty much now ubiquitous USB charging lead, USB-C, okay. It comes with some, let's have a look at them, fairly standard multimeter leads. Not the needle sharp ones I prefer, but I think most people who buy multimeters end up using their own types of lead. This is interesting straight away because this only has two contacts. That makes me think that this doesn't measure current. Okay, that's what I think. Let's see if it's charged. Yeah, hold the button. IRRDMM, it powers up. I think we've gone directly into the thermal camera. Yeah, okay, so let's try the first trick. Yeah, move the hand, it leaves a nice trace, so that is a good thermal camera. Refresh rate is nice. Okay, so first glance, thermal camera is working quite nice. It comes with a little user manual. Have a quick look. This must be the macro lens. That clips onto the back of the meter somehow. Again, I'll just have a quick look at the manual, but this I'm pretty sure is the macro lens. In fact, is it just obvious how this goes? Yeah, there's two holes up here. And it seems to be like magnetic or something. Yeah, it's on there. Oh, yeah, that's also working very well, just on my hand. Yeah, okay, so macro lens is on. DMM, multimeter. So volts, DC, AC, diodes, resistance, non-contact voltage, capacitance, continuity. Yeah, that's like a temperature. Oh, it has a temperature measuring. That must be with a thermocouple. Or is that with a thermal camera? No, that appears to be using a thermocouple. Yeah, has some sort of readings over time. I'll tell you what, I'll just stop messing with this and we'll try it. I'll just read the manual a little bit. Oh yes, I can say sampling period and stuff. That is what I thought it was, okay. Yeah. Okay, let's try the multimeter. So just looking at the specifications of the thermal camera, it is what we said, okay. Again, it doesn't mention the refresh rate here, but I have read it, of 20 Hertz. Multimeter, maximum voltage, maximum capacitance, resistance, the normal stuff. Diode test range up to 3 volt. Continuity up to basically 1K. So the AC volts has 400 millivolts, and the DC, yeah, the ranges are the same, okay. So this will read to 100 microvolts, 0.1 millivolts on both AC and DC. That's fairly common. I have multimeters which are much more sensitive, but for instance, my Fluke reads to this. Resistance to 0.1 of an ohm, diode test, capacitance, and as we know, there is no current range on this. That's a bit strange. That seems like a really strange omission to me. I do not see why this does not have a current range. Obviously, I didn't design it, but I really don't see why. It kind of like stops it being an all-in-one use meter. Okay, we don't always want to measure current, but I would like to see that on here. I just don't really see why we don't have that. Okay, but we can have a quick look. So we can just have a play around a few resistors, diodes, continuity. We'll see how it blips and when it blips. And then I think we can just try the thermal camera. I'm fairly confident the voltage range will read voltage. We can check something coming out of my power supply. So let's just have a few tests with this and see what we think. I've noticed it's fairly easy to get marks on this. I'm not sure if this actually has some sort of like protector on it, but I can't see any way to lift it off. It looks that way. You can see like the reflection in it there, but if it has a screen protector on, I don't see how that comes off. There'd be like a little tab or something, and there isn't. And it doesn't mention that in the manual either. Okay. So, resistance range. A lot of multimeters struggle with very low value resistors. This is a dual 0.22 ohms. So from the center to there is 0.22. That is 0.22 and it's 0.44 across the outer ones. I've noticed when you switch this on, it seems to go directly into thermal camera mode. You press the button to switch it to multimeter. Yeah, I am correct. It does go into the thermal camera mode from power on. And the interesting thing is you can't switch it to multimeter mode until the thermal camera is booted. I'll just show you that again, actually. So hold the button in to power it off. Okay, hold the button in to power it on. It's now coming up into the thermal camera. It's counting down 6-7 seconds. And while it's doing that, I cannot switch this into multimeter mode. I have to wait, even if I only want to use the multimeter. Okay, so this is what I was mentioning about implementation of this. Yeah, maybe I was a little bit wrong. I mean, it's not like a major problem, but I would have thought that you'd be able to get into the multimeter when you first power on without having to wait 6 seconds, okay? And I need to mention that. Okay, so resistance range. 0. What does this read? 0.1, 0.2. Then it goes to 0. This is a problem a lot of multimeters have with low value resistors. It's actually got that one, 0.2. Oh, okay, no, it is reading it, I'll be fair. And then if I go across the resistance, should have 0.4. Yeah, that works well. I mean, a lot of multimeters, my Fluke, for example, won't do it. They read 0 quite often. What I have noticed with this off camera, by the way, is that if you leave it for a little while, it goes like to a sleep mode. And if you touch the power, when it wakes up, it does come back into the mode you were previously in. In fact, it's just done it there. It's gone to sleep, touch the button, and it stays in multimeter mode, okay? So I'll give it that. This is a high value resistor. This is 4.7 meg. So let's try it. Yeah, it readies. I will say the auto ranging on this is fast. Some meters, like you'll see, they go through various ranges. This is quick. I do like that about it. These things here, these are not buttons, by the way. They're just like decals, what I call them. Icons that represent the various modes it has, but these are not actually switches. To switch it, you do is on the screen. Continuity. That's pretty good, pretty fast. Not possibly the fastest, but it's pretty fast. Right, so let's get some diodes. So this is the Mr. Bleep test, as we call it, yeah. I'm on continuity mode. I'll just touch it because it was going to go to sleep, I think. So I'm expecting that continuous bleep, and it probably won't read the diode in this mode. That's interesting how it goes to like 0. Oh, yeah, it's just doing that by itself. Yeah, if I just attach a diode, it's doing that by itself. Oh. What is this doing? I mean, why is it doing that? Yeah, try the Schottky diode. Same thing. 3 times there, and then stop doing this. Do it again. Doing it continuously. Right, let's go to diode mode. Okay. Normal diode 1N4007. Well, that's backwards. Let's go the other way. Ah, so it does give a bleep. Okay, let's go to the Schottky. And it does give a bleep. What happens if it's short? Wow! Guys, it does the Mr. Bleep test. It passes. On diode mode, continuous. Somebody's listened to me. Single bleep 582. Single bleep 172 on the Schottky. Continuous. Right, so in my opinion, you don't use the continuity mode because it does some very strange things. But the diode mode actually works on this thing. Yeah. Right, I'm going to take back some of what I was saying about this. It's got some quirks, but I've just got to give it a big bonus for that. You've got that right. Let's have a look at the capacitance test. So normally with a multimeter, we know this, the higher the capacitance, the longer it takes to take a reading. And a very large capacitor can take quite some seconds. 100 nanofarads. I don't think my fingers are affecting the reading there. Well, it reads about 60, but I'll be honest with you, these capacitors, I've done them before and they seem to read about 60. Let me try one of these. Yeah, 101. So that read quite accurately, I think. Try a higher value. So this is 2200. Wait, yeah, wait, keep waiting, and it reads it, 2336. So that's pretty accurate, and that time, that's normal for multimeters, they all do that. If you want to read these things instantly, you need a dedicated capacitance meter. This has an auto range, so it reads short. If I connect to my bench supply, which is set to 1 volt, yeah, it reads 1.26 volts. If I measure me, that's my skin resistance, about 300k, so that does work. Non-contact voltage, let's try this. So this is just a mains lead, not connected to anything, but plugged into my power socket. Yeah. That works. Okay, so I have to say the multimeter is a bit quirky. Yeah, you've seen what it does. It does have a range where you can sample readings over a period of time. Okay, I had to just check the user manual for this one, but this has this sampling mode. So we click on this little waveform thing here, and we can see the screen. Okay, then there's a play button and the start the screen. So I press the play button. Yeah, and it's now running. Can you see the graphs moving at the bottom there? So if I now alter the voltage, for example. Yeah, can you see on the graph? So that's 32 volts going up. And it's showing me a scale on the side here, 20 volts, 40 volts, and so on. The scale seems to be automatic. So it's not exactly this is an oscilloscope, but it kind of like shows you the variation of voltage over a period of time. Okay, so we have that as well. Could be useful in some cases if you want to sort of monitor something to see if it's changing. Now let's have a look how well the thermal camera performs. So I'm just going to get a motherboard and power it up so we can actually have a look at stuff. We'll try it without the macro lens and then with. Because the macro lens is on, I'll use it with first and then we'll try it without. I've noticed, by the way, the macro lens is recessed in here, so if you put this on a desk or something, you're not going to scratch that. That's a good thought, of course. So quick touch, it's awake. We can see this motherboard. I'll try and do this so you can see well without getting the glare. Everything's cold at the moment anyway. Okay, let's power this up and let's see if something warms up. Yeah, well, straight away. Can you see that? And it's telling me at the top it's 40 degrees. I can see the temperature. I have a few settings here: system, backlight, sound, infrared camera. Oh yeah, I can set it to Fahrenheit, to centigrade, temperature level, low, high or auto. Colour tables, this will be effectively give it a second. Yeah, these are like different rainbow effects if you like. Okay, let's try something else. I have to say that macro lens is pretty good, and I'm not getting the reflection like you are, guys, but that's because the overhead lighting. In fact, let me just switch the overhead lighting off a moment, make it easier for you guys to see. Okay, so I've turned the overheads off now. Yeah, so the screen is actually fine. It's just I have some very bright fluorescent strips. Okay, 49 degrees, you can see that. We're still getting some reflection. I still have some lighting on, by the way. I'm not in the dark. That's this chip here. have to say the thermal camera is pretty good. I mean, I can see down here, if I show you, I can easily see individual transistors. Okay, you can see them, all the little components. It's just gone to sleep. Let me wake it up. It wakes up instantly. So I can easily see all these individual. That's the tiny little transistors here. This is the VRMs this side. Let's have a look. Yeah, we can see that whole area is warm. Again, I can clearly see all the tiny little components down there. VRM controller down there at 51 degrees. Okay, let's take the macro lens off. Comes off very easily. Now let's have a look. Yeah, even without the macro lens, I can see a lot of very small components. It doesn't focus quite so closely. So I'd say for the additional cost, the macro lens is well worth having. Okay, you can compare that. It's magnetic, this is held on, by the way. Yeah, you compare that with that, so you can see clearly there's a difference with the macro lens. But the thermal camera, I think, really works well. There's not much lag. It's just doing a recalibration then. Thermal cameras do this. I'm thinking you can probably adjust the time that takes to go off. I haven't actually looked. Oh, we can save pictures on it. I've just found that as well. Yeah, we can save images. Okay. Yeah, that is pretty nice actually. So we have to sum this up, guys. Right. I did say this is down to implementation. Multimeter first. I just don't see why you don't have a current range on the multimeter. I just don't get that. Why is there no current range? That's what I would expect. Otherwise, I need more than one multimeter because this won't do everything I want to do with it. That's the first thing with this, yeah. The continuity range acts a bit strange. It works. You get a bleep on continuity, but when you connect diodes, it keeps flashing from 0 to over limit and doing that continuously. I have no idea why, but when you put it into diode mode, this has missed a bleep basically, and that was spot on. Yeah, so I have to give it good marks for that. And if you have one of these, just use it in diode mode and use that for your continuity as well, because it works fine as continuity, and it also works great with those diode junctions. So that, excellent. Okay, somebody has implemented that, and I've been asking, I know you guys have been asking for that for a long time. Top marks for that. This business of having to wait when you switch on before you can get into multimeter mode is a bit annoying. At least a bit annoying. So look, it's counting down and I cannot get into multimeter mode until it finishes counting down. I mean, once you're in multimeter mode, or for that matter in the thermal camera mode, if it goes to like sleep, you press the button, it wakes back up in the mode it was in. At least that is good. But when you switch to the thermal camera, you get this countdown. But to be honest, all thermal cameras do this. They take a few seconds to set up, so I wouldn't say that's anything different. I just wish with this being a built-in multimeter, you could switch modes. The resistance range worked well on low value resistors. A lot of multimeters don't, so that's fine. Diode range worked based as expected. Non-contact voltage seemed to work fine to me. Okay, so it's an okay multimeter. It's just a bit of a missed opportunity in my opinion. And the reason it's such a missed opportunity is because the thermal camera is really good. I mean, with that macro lens on there, you can really get close to this and see stuff. Yeah, look at that. You see, so you can see all those tiny little components, yeah? All of them. So the thermal camera, I think, works really well. And for the price of this, for a thermal camera with 192 by 192 resolution and a decent refresh rate, that is pretty good. Okay, as far as I can see, you can't connect this to your computer or something to view on a bigger screen. But there again, not all thermal cameras actually do that anyway. And I think it's a handy tool. I mean, I can't knock this fair enough, especially again if you're out and about on site, or if you just have it on your bench. It's very easy to grab this and just look at something if you like, and also, you know, take a few measurements. So, you know, a lot of my reviews, guys, make your own mind up. I think it's nice, but I also think this is something of a missed opportunity, and it could have been great with just a few differences. Okay, hope you enjoyed that. Maybe you agree with me, maybe you don't. Get to the comments below, let's all talk about it. I would certainly consider this if you don't have a thermal camera. Let me know if you're thinking of buying one. Okay, thanks for watching. I'll see you all soon on All In Electronics Repair. Ciao for now, guys.